All right, here's a quick one. It was just to make sure that we've actually had this discussion. You could have answered this back in chapter 5. If I have a car traveling on a road and I have the velocity function for that car here, this is v of t, can I find the integral from 0 to 24 of v of t, and can I explain the meaning of that integral? Well, here, this integral I'm going to evaluate using areas. I notice that this area seems to be a trapezoid. Here I have no complications. I have no negative velocity. So straight up area under the velocity curve. This is going to be that 12 is the length of the top of the trapezoid. 24 is the length of the bottom. I'm going to multiply by, I'm going to divide by 2, so I'm finding the average, and I'm going to multiply by the distance across the other dimension, which is 20. My units are going to be meters per second times second, which is going to give meters as my answer. And then can I explain the meaning of this? I'm going to type it up and then point out the 4 important pieces that your explanation needs to have. All right, so my typing tool can't create that integral, but I would write this integral. I've been asked to explain the meaning of the integral, so I'm going to say the integral from 0 to 24 v of t dt is the distance in meters that the car traveled over the time interval 0 to 24 seconds. So to get credit for an explanation like this, you absolutely need 4 parts. So number 1, you have to tell me the kind of quantity that integral represents. So we said area under the velocity curve is distance traveled. Here, I could have said displacement. I could say distance. I could say total distance traveled, because in this case, when velocity is positive, they are all equal. So I chose to write distance. And to say the quantity described by that integral, you have to give units on that quantity. So it's your job to figure out that if you have velocity measured in meters per second and time measured in seconds, the area under that velocity curve is going to be given in meters. You need to name the other quantity too, the quantity for like the input variable that the car traveled. So distance is pretty good, but you're going to want to be specific. You're going to want to tie it to this scenario. So distance that the car traveled. And then the other 2 pieces you need are the quantity for the input variable. You can't just tell me, you can't just call it t, you have to call it what it represents. So usually that's printed along the axis. We call that the independent variable. This is time. So I would say over the time interval 0 to 24 seconds. This last one is the one that people leave out. You're not thinking so much. You say I've figured out the units for, the quantity they really asked about. But you have to give units on the input variable too, otherwise your explanation is not specific enough. So final answer for this old released free response question. So here I have a question. This is a calculator active question, which is really good luck for us because we've been asked to, given this velocity graph, say the total distance traveled by some particle. I've been given the velocity function for the particle, and I want to know the distance, total distance traveled. So we said just a few moments ago, I can compute total distance traveled by integrating over the time interval, in this case 0 to 3, the absolute value of the velocity function, which happens to be called v of t. I'm going to need a dt here. If you wrote this integral expression with the absolute value bars and the correct limits on your test paper, that's worth 1 point. If you then correctly type it into your calculator and report the final answer, that's worth a 2nd point. So give me a second, I'm going to calculate this. All right, so I'll show you what I do if I need to evaluate an integral and I can't find my calculator, which is happening right now. This is wolframalpha.com. They have a little calculus section, and they have tools online for integrating. So here's a place I can compute integrals. This is a definite integral I want to compute. So I'm just gonna delete out the example they had there, and I'm going to type in this one. I've already typed it ahead of time. I want to integrate the absolute value of sine of x squared from 0 to 3. So integrate, see the absolute value bars, sine of x squared dx from x equals 0 to 3. And hit enter. We'll make a picture which should look like the picture that we saw in the handout, but with the negative parts flipped up. Oh, it's taking a long time to compute. They're going to try to sell me the enhanced product. All right, so I didn't happen to get a picture that time. Most of the time this site will give you a picture. So there's my answer, 1.702. Remember to give your answers to at least 3 decimal places for full credit. All right, so we said that's 1.702. And then this next part, find the position of the particle at time t equals 3. This is like the most important example in chapter 5. So my position, I know x of 0 is 5. I need to know x of, well, let me write x of t, and then we'll talk about finding x of 3. X of t, I know the derivative of the position function, its velocity. So I'm going to write v of, I'm going to use any other variable. I like to use v of p dp. My limits are going to be, my upper limit's going to be t. My lower limit is going to be this x value that I have a value, the input value that I have an output value for, so this was 0. And I know when time is 0, the position is supposed to be 5. So it's 5 plus the integral from 0 to t, v of p dp. And I'm going to come up here to do the last step. I've been asked to find the position at time 3. I'm going to call that x of 3. And that's going to be 5 plus the integral from 0 to 3, v of, at this point you could use any letter you want. You could go back to t's. If you don't have any t's here, I'm just going to leave the p. This part you can use your calculator to help you find. I'll do that next.